So this goes to the idea of what can and cannot happen with addition and subtraction. You cannot add cats and dogs. That's why the idea of what the unit is, in this case dogs, cats, is important. Now you can add 3 cats and 4 cats and get 7 cats. And then the 2 dogs you just put here, but you cannot add them to the 7 cats. Now, likewise with this is just the expanded form of a number. All addition follows the same logic. Here is 3 of these hundredths and 6 of these hundredths. That's 9 hundredths. And I can add to that 2 tens. I can't add it to the 100. I add it here. 2 tens is 20. And then I have 4 ones and 3 ones, which is 7 ones. So this number is 927. This is like a little algebra, but it's the same thing. I can add x's and x's just like I can add dogs and dogs. So I get 16 x's, 16 of those. And I have 7 y's, and I can take 3 y's away, and I have plus 4 y's. That's all I can do. Down here, this is the same idea, just with some exponents. I have 5y squared, but there's no other y squared. So I'm going to just put down 5y squared. And then I have 6t squares and 7t squares. That will give me 13 of these. And then I have 3y's and 8y's, and that'll give me positive 11y's. Fundamental with addition and subtraction. You can only add the same units. Okay, we're just going to add some fractions here, right? But it follows the same logic. These are 6 and these are 8s. They're like cats and dogs. You cannot add them. But what you can do is try to change one or both of these units so that they're the same. And so I have a 6 and an 8. I'm looking for called the least common denominator or multiple. Hopefully you see that's 24. So I could change 1 6 into 24ths. And then I'm going to change 3 eighths into 24ths. And then I will be able to add them. So 6 times 4 is 24. 4 there, 4 there. 1 times 4 is 4. 8 times 3 is 24. So a 3 goes there, and that's 9 24ths. So here I can add the 4 and the 9, right? I don't add the 24ths. That's what it is, right? When you add 3 cats plus 2 cats, you get 5 cats. You don't add the cats and get cats squared or whatever. Same here. So I'm going to have 13 24ths as my answer. Notice I did not add these things. I changed them so that I could get the same unit. Now, subtracting here, it's the same problem. But notice that 8 times 2 is 16. So I can change 3 eighths into 16ths by multiplying by 2 over 2. It gets 6 16ths. Notice that 3 eighths and 6 16ths are the same number. They're identical. So I can just swap out 3 eighths for 6 16ths minus 3 16ths. And I'm going to get left with the units, right? But I'm going to subtract how many I have here from here. So now I'm going to add these all together here. What I'm going to do first is notice that I'm going to write these out this way. 4 plus 3/4 plus 16 plus 7/8. Now with addition, I can just go ahead and add in any way I want. So this is, the whole numbers are 33. Now I just have to add this, this, and this fraction. So I have eighths, fourths, and halves. Eighths, fourths, and halves. The least common multiple, or the common denominator, would be eighths. So I'm going to change 1/2 into eighths, and I'm going to change 3/4 into eighths. 2 times 4 is 3, 8, and 4 times 4 is 4. 4 times 2 is 8, 3 times 2 is 6. So this is, I'm going to change color here, keep it clear. I'm going to change that to 4/8. I'm going to change that to 6/8. So I'm going to add all these up. I get 10 17/8. But that's an improper fraction. So I have 33. I'm going to change this to a mixed number, plus 2 plus 1/8. So my answer is going to be 35 1/8. So you should have gotten that. There's a lot going on here. Change the following into improper fractions and then a mixed number. So 5 to the negative 1, I have 7 of these. So I have 7 of these. And here that would be 1 2/5. So there's your improper fraction and your mixed number. Here I have 65 of these. 8 to the negative 2 is the same as 1 over 8 squared, which is the same as 1 over 64. So this is 65 over 64, which is 1, because 1 is 64 over 64, and I have 1 left. So there is as an improper, and there is as a mixed. Okay, so this is just a review again of greater than, less than, or equal to. Notice that 6/5 is less than 1, 6/5 is greater than 1, actually it's 1 1/5. And this is less than 1, so this is the bigger number. 1 equals 1. This is 2 plus something, and this is 1 plus something. So this is obviously bigger. This is 1 times 1, and this is 1 times 1. They're equal, right? This one is 3/10 times this is 3/10. And 3/10 is 0.3. So this is 0.3 over here. And this is 3/10 plus 1/100th. So this is greater. This is 2 over 5, and this is 0.4. Let's change the 2 over 5 to a tenth, right? So I can write it as a decimal. So they're equal. Make sense here? So I'm going to change this to a mixed number and then a decimal. So 1/2, changing it to a decimal, I need it to be tenths, which I know 2 goes into 10, right? 2 times 5 is 10. So if you didn't know that, you now know that that's 5/10, or 0.5. And 5.2 is 5 2/10, or 5.2. So here I'm going to get 5 7/10 as a mixed number, and as a decimal 5.7. This one is 2 plus 3/10 plus 4/10, which is 2 7/10. Writing it as a decimal, 2.7. So just to show you, the math that we've learned comes into play with algebra. First, I'm going to combine these because these are the same thing. The units are the same, so I can combine these. And I don't care how many 11 are. I want this to be solved for 1r. When I just write that, that means that, 1r. Divide this by 11. 11 by 11 is 1. Divide this by 11. That's 3. So the answer is r equals 3 to make this equation true. These I can combine because they're all the same unit. 11x's minus 3x's is 8x's. Right? 11 minus 3 is 8. Equals 34. Divide by 8. Divide by 8. So you can write that as 34 over 8, or you can write it as 4, 32 and 2/8, which reduces to 4 1/4. What is this? 6 over 6 is 1. This is 2x. 1x plus 1x is 2x equals 12. Divide by 2. X equals 6.